Alrighty, everybody. It looks like we got our okay to start our planetarium show. So put away those space trivia questions because now, folks, we're going to be heading into the unknown. Ooh. And welcome everyone to the Morrison Planetarium. Really quickly, I just want to introduce myself. My name is Christian. I want to be your planetarium presenter, and I'm very excited to have everyone here today because you're my favorite place in this entire universe, which is the Morrison Planetarium. And the reason why is because everything that you see in purple right now is going to be one really big screen, thanks to the help of 6 different projectors hidden throughout our planetarium dome. If you're looking for our projector system, it's hidden just below the purple glow. And folks, the show that we're going to be watching right now is by far my favorite show to do here. This is different from all the other ones we've done so far. This one is called Tour of the Universe. And folks, with Tour of the Universe, this show is completely live, so you're going to hear my voice for the next 30 minutes as I free fly us through space. And also, we're going to be starting off pretty close to the Earth, and we're going to be zooming all the way out to the very edge of the observable universe. So hopefully by the end of the show, you won't have an existential crisis of where we are in space. But just a heads up, we're pretty small in the grand scheme of things. And before we get started, I do have to go over some quick house rules just so that we're all on the same page. First off, folks, there's no food or drinks allowed in. If you brought any snacks, make sure those are put away. We want to keep the theater nice and clean. It's hard to clean in between shows. Also, if you got any cell phones, smartwatches, anything that produces bright white light, now's a good time to put them away for the next 30 minutes as these can be very distracting and takes away from the planetarium show experience. And folks, if you need to leave early, the exits are always going to be at the top of the planetarium, so always make your way up the stairs to exit before, during, and afterwards. And if climbing the stairs is a challenge for you because the staircase is very steep, just remain seated. Once the show's over, we'll have someone escort you to a lower exit. So as people are making their way up to exit, just stay seated for a bit longer. And folks, this show is very immersive thanks to our 75-foot dome above us. If at any point during the show you start to feel overwhelmed, you start to experience motion sensitivity, there's a really quick and easy trick to ground yourself. All you gotta do is close your eyes, take in a few big deep breaths, then your brain will remember that you're sitting in a planetarium in San Francisco and not hurtling across the universe, at least not more than the usual. Hee hee hee. But with that being said, it looks like we're ready to go. So I invite y'all to sit back, relax, and let's begin our tour of the universe. Alrighty, folks, we're going to be starting off pretty close to the Earth. We can see the curvature of our planet. We can see all the city lights down below. But we're starting off at this spacecraft right in front of us called the International Space Station. We also like to abbreviate it by calling it ISS for short. And a lot of people tend to ask me, hey, Christian, what is the International Space Station? I hear it in articles and news clips, but I don't really know what it is. Could you explain it for me? Well, of course, folks. The International Space Station is a research facility. It's a laboratory that orbits around our planet Earth. And they conduct all sorts of different experiments all the way up here with less gravity. Some of the experiments they'll conduct are things like what happens when you try to grow plants in space, uh, which way do the roots grow with less gravity? Another one is what happens when you try to spark a match in space? Does the flame act the same? Does that act differently with less gravity? And one of my favorites is where they had 2 identical twins. One twin lived on Earth for a year, the other one lived on the International Space Station for a year. After that year, they compared and contrasted the 2 twins. Turns out when you live in space for a long period of time, you tend to age a little bit slower. But not only that, you also lose a lot of muscle because you don't have gravity constantly working down on your muscles all the time. So if you plan to live in space for a long, extended period of time, remember to exercise daily. And folks, this space station looks really big here in our planetarium dome, but it's not that big in actuality. It's only about the size of an American football field. If you've never been to an American football game, you can also use the entire California Academy of Sciences, the museum we're sitting in right now. That's about how big it is. And what's really impressive is that this thing is going incredibly fast, folks. The International Space Station is traveling at a whopping 17,000 miles per hour, where it orbits once around the Earth every 90 minutes. And it experiences 16 sunrises and 16 sunsets a day. Whew, how romantic. Also, this looks really far away from our planet, but it's not that far either. The International Space Station is only 225 miles above the surface of our world. 225 miles for us Californians, that's not too far away. That's like going from San Francisco to Santa Barbara, a nice little road trip to get away with the family for the weekend, so not too bad. But to tell you the truth, folks, this is as far as we put humans out into space nowadays. only 225 miles above the surface of our world. The reason why? Well, it's very expensive to travel in space. You got to build yourself a rocket ship or buy one. Then you have to get all that rocket fuel. You're going to need so much for rocket fuel. You got to be able to escape the Earth's gravity. Then now that you're in space, you have to account for all the food, water, all the air you're going to be breathing while you're up here. So the bill gets quite costly quite rapidly. But folks, the International Space Station is just the first stop in our tour of the universe. So now we're going to see it slowly disappear to the city lights down below. I want to add a nice little orbital path so we can see it as it slowly fades away. And it looks like we're hovering just above India right now. And now, folks, we're able to see our entire planet Earth. And I want to let you know, real quick, folks, that this space program that we're using here in the Morrison Planetarium is something that you can go home and download, and you can fly through space just like how I'm doing right now. This space program that we're using is called OpenSpace. So if you go to your favorite search engine, type in OpenSpace project, you'll come across the link where you can download this. So remember to add project at the end because otherwise you'll get a furniture store. And also, folks, this this space program, OpenSpace, in its beta phase, which means it's not completely finished. So they're still adding to it. We may come across a few bugs and glitches. If we do, I'll point them out. Hopefully, we can look past them. Also, this uses a whole lot of processing power and information. So if you wanted to download this and you have an older computer, you may want to rethink it. But if you got something new or a gaming computer, give it a try. It's a whole lot of fun. But if you're a person like me that doesn't want to download anything because I don't have enough space, well, there's another great alternative program called NASA's Eyes. Just like the human eyeball, type in NASA's Eyes. Don't have to download anything. You can fly through space, and it's so much fun. But in here, we're using OpenSpace. But now that we got a sense of what we're using in here, let's make our way over to our nearest natural neighbor to us in space, the moon. Now, folks, we humans have been to the moon before. That was between 1969 and 1972, thanks to NASA's 6 Apollo space missions that brought a total of 12 incredibly lucky guys to walk on the surface of the moon. They got to conduct science, and of course, they had some fun up here as well. They got to play some golf. But again, last time we sent humans to the moon was 1972, a little more than 50 years ago or so. But don't worry, folks, NASA has a new space mission in the works that's going to be sending humans to the moon in the next couple years. This new space mission is called Artemis. You may have heard about it in the news because they just announced the next 4 astronauts that are going to be flying around the moon on Artemis 2. But pretty much the main goal with Artemis and this space program or space missions is that NASA wants to send humans to Mars. But before we send humans to Mars, we got to figure out exactly how we're going to be living out here in space. And the moon is the perfect stepping stone about how we're going to be figuring out the logistics of how we're going to be doing that. And what's really cool with Artemis is that they're going to be sending the first woman to the moon, but not only that, they're also going to be sending the first person of color to the moon, but not only that, they're eventually going to set up lunar bases throughout the moon. Pretty much our technology has greatly improved in the last 50 years, so we're able to do much more science in much more compactable size. And one place that we definitely want to set up a lunar base is the south pole of the moon. The reason why is because we found ice there, and ice is going to be very helpful because we can melt that ice, get liquids, water from it, pass electricity through it, and then get hydrogen and oxygen, and both that stuff is very valuable when you're way out here in space. But again, folks, we humans should be heading back to the moon in the next couple years, so look out for any news about Artemis. Good stuff. And sometimes, folks, when we look up at the moon here on planet Earth, sometimes it feels incredibly close to us. It feels like you can reach out your arms and touch the moon. But the moon's really far away. It's about 240,000 miles away from our planet. 240,000 miles. Some of the adults in this room may have a car with that many miles on it. And if you take better care of your car than I do, you can even imagine driving to the moon if you drove for about 4 months nonstop, going about 80 miles per hour. Although I wouldn't recommend it, the roads out here are poorly maintained. Hee hee hee. And from here on now, folks, we're going to need to use a more useful measuring stick because at this scale, using miles, that's kind of like using inches to describe distances between the cities. So because space is so big, astronomers use a more convenient measurement known as light speed. And light travels at a mind-boggling speed of 187,000 miles per second. That's roughly about 300,000 kilometers per second. So while it took the astronauts more than 3 days to reach the moon, traveling faster and farther than any human has done so or since, it takes light only 1.5 seconds to cross that distance at the speed of light. That's kind of like a short pause in conversation. But at last, folks, it's time for us to leave the moon behind, so everybody say bye-bye, moon. See you later. So cute. And now, folks, we're going to see the moon and the Earth's orbit as they start to slowly disappear. In fact, before we lose the moon, I want to add some nice planet trails because, again, space is so big, you can easily lose stuff out here. And now, folks, on our journey, we're going to be traveling much faster than the speed of light. We're going to be traveling at the speed of the human imagination, thanks to the help of computer models like OpenSpace, showing us the most accurate images and information available to us. And now, the nearest star to us, the sun, should be coming into view. So here comes the sun. Do 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 do. There it is. And again, folks, the sun is incredibly far away as well. The sun's about 93 million miles away from our planet Earth. Whew, 93 million miles. That is a good distance away. But in terms of speed of light, that's not too far away either. In order for sunlight to travel that 93 million miles, it only takes sunlight about 8.5 minutes at the speed of light to reach our planet Earth. And this is a really cool concept because let's say the sun was to turn off all of a sudden, we wouldn't know about it here on Earth for about 8.5 minutes because that last bit of sunlight will travel that 93 million miles at 8.5 minutes, and then all of a sudden the daytime on Earth would become nighttime. And again, folks, this is such a cool concept to keep in mind because let's say we're looking at a star that's 70 light years away from us. We're looking at that star as it looked like 70 years ago because the light that just reached us took 70 years to get to us. So when you look at really far away objects in space, it's kind of like looking back in time in a sense. Pretty cool. But now that we have a nice bird's eye view of our solar system, we're going to do a quick refresher of what we have. In the middle of our solar system, we have our sun, the biggest thing, our star. The closest planet to the sun, we have Mercury. Then we have Venus, Earth, that's us, and Mars. These are the rocky terrestrial planets. These are places where we can actually land a spacecraft on. Although a couple of them you don't really want to because it's really, really hot on those planets. And then past the orbit of Mars, we have this really cool thing called the main asteroid belt. And this is what it would look like to highlight all the asteroids. There is a lot of them. And then past the asteroid belt, you have the really big planets, the gas giants, the Jovians. We have Jupiter, the largest of them all. Then we have Saturn, famous for its rings. And then now we have our icy gas giants. We got Uranus, the funny one, and Neptune. And of course, we can add everyone's favorite lovable dwarf planet, Pluto. So here's the orbit of Pluto on screen. Just popped up on the very bottom left of our screen. And a lot of people don't realize that Pluto hangs out here in this outer part of our solar system called the Kuiper Belt. And you're probably wondering, what's the Kuiper Belt? I've never heard of that before. Well, folks, this is the Kuiper Belt. So the Kuiper Belt's like a second asteroid belt way past the orbit of Neptune. What you're mostly going to find out here are icy asteroids and short period comets, comets that don't stray too far away from the sun. And we came across the Kuiper Belt in about the year 2006 because our space telescopes improved and we're able to see much smaller objects much further away. And we found more than 400 objects out here, and some of them were bigger than Pluto, so we couldn't call all this stuff planets. There was just way too many of them. So all the astronomers across planet Earth had a great big meeting. They had to figure out what exactly needed to be considered a planet. They came up with 3 criteria, and that was the day Pluto went from being a planet to a dwarf planet. And that's the really cool thing about science, because as our technology gets better, we're able to reclassify the science that we already know. So science is constantly changing. And folks, I'm going to be putting away the Kuiper Belt because that's just a whole lot to look at. And now I'm going to be adding on screen the many different spacecrafts we sent out in the 1970s to explore our solar system. On screen, we have the trajectories of Pioneer 10, Pioneer 11, Voyager 1, and Voyager 2, and the latest of them all, New Horizons, which flew by Pluto in 2015. Now, all of these spacecrafts are all traveling fast enough to escape the sun's gravity and leave our solar system behind. But even the most distant of these robot adventurers, Voyager 1, has not traveled as far as light travels in a single day. In order for sunlight to travel all the way out to the orbit of Pluto, takes about 5 hours at the speed of light. 5 hours, not too bad. But now, folks, it's time for us to leave our planetary scale behind us because now we're going to be heading out into interstellar space, the space between the stars. distance now becomes so immense, it's going to take us about 4 years at the speed of light just to reach the next star system to us, the Alpha Centauri system. Ooh, it looks like Alpha Centauri is just right above us. We're right in the middle of our screen. Alpha Centauri is a little bit towards the top right. We could see it moving right over there. And again, folks, 4 years at the speed of light just to reach the next star system to us. But that doesn't really put into perspective of how long it would take us humans to travel that distance. Well, folks, if you're getting a rocket ship today, left our planet Earth over to Alpha Centauri, it's going to take you about 8,500 years to make that trip. Whew, and that's just a one-way trip. But let's stop and consider whether humanity has made its presence known beyond our solar system, because now, folks, we're going to be stepping inside something called the radiosphere. And again, we're now inside something called the radiosphere, and this represents the current limits of the most distant radio signals humanity has ever broadcasted, or rather leaked into space. And it extends about 90 light years in all directions, emitting out from the Earth. This first began in the early 1930s with strong radio waves, early television, and radar signal, and then later the detonation of atomic weapons. All this stuff is emitting electromagnetic radiation strong enough to escape the Earth's ionosphere. And humans were broadcasting well before that, but the earliest radio was not quite powerful enough to escape the Earth. And since all these signals are electromagnetic, they are traveling at the speed of light, so this is kind of like humanity's electromagnetic footprint in the universe. And of course, folks, the radiosphere is constantly expanding at the rate of 1 light year per year. So is anybody out there listening? And now, folks, I'm going to be adding some many markers onto the screen. These many markers indicate some of the many thousands of stars astronomers have discovered over the last 30 years, which has at least one or more planets orbiting around them. We call these planets exoplanets, and we're looking for any of them that are Earth-like with conditions suitable for life as we know it. So far today, we found more than 5,000 confirmed exoplanets in the nearby vicinity to us. 5,000 other worlds besides our own. And that 5,000 number is going to be increasing because we have space telescopes where their whole purpose is to find as many exoplanets as possible. In fact, if you look towards the top right of our screen, you're going to see a whole heap of exoplanets because we pointed our space telescope in that direction for about 5 to 10 years, and there's a bunch of exoplanets. So as they continue to scan more and more of the night sky, they'll be finding exoplanets left and right. Now, to say if any of them are Earth-like with conditions suitable for life for us humans, well, we can't answer that question quite yet. Pretty much new space telescopes are being developed right now, made, so it's going to be a few years before we can answer that question. But the more important point here is that quite a few of these planetary systems are within that 90 light year limit of our radiosphere and could have potentially received our signals. However, since radio waves travel at the speed of light, if there is anybody that's out there able to listen in and answer back, the communication delays between hellos could be decades in time. Now, to give you an example, let's say we live in a star system on the left-hand side of our radiosphere. We find an alien civilization somewhere on the right-hand side. We send a message. We say, hey, we're humans. We live on Earth. Takes 60 years to get to them. They listen in, answer back. Another 60 years to get their response message. Folks, that is a 120-year conversation in the making. And I could barely wait for a text message from my friend. But of course, folks, planetary systems beyond the radiosphere, more than 90 light years away, have not heard from us yet, but eventually they will, as the radiosphere is always growing, but it becomes weaker as it does. And I want to put away those exoplanet markers, but I'm going to leave our radiosphere up on screen, because as huge as humanity's electromagnetic footprint is, it is nothing compared to our Milky Way galaxy. Alrighty, folks, we're looking down our Milky Way galaxy. This is the galaxy we live in, and I've got to ask, can anybody see their house from here? Just kidding. And folks, our Milky Way galaxy is incredibly large. If you wanted to cross it from one side to the other, it's going to take you about 130,000 years at the speed of light. Whew, it is big. And it's so huge, we estimate that there's at least 300 billion stars in our galaxy. If our recent discovery of so many exoplanets just within our small neighborhood within this vast star city is any indication, there could be billions of planets and potentially millions of Earth-like planets throughout our single galaxy. And before we leave the Milky Way, I want to show you what it looks like from the side. We live in a big, flat spiral disk of the Milky Way plane, kind of looks like a big pancake or a frisbee in space. And this is important, folks, because when scientists want to learn about the universe, it's easier for them to point their telescopes galactically north and galactically south, instead of looking to the plane of the Milky Way galaxy, because here you'll have a bunch of stars, planets, gas, debris, things that block their view of the universe. So again, it's much easier for scientists and astronomers to point their telescopes galactically north or south. So keep that in mind. That's going to come important in just a little bit. But folks, the Milky Way galaxy is only one of many hundreds of billions of galaxies that comprise the known universe. So in this giant leap, folks, every single point of light that you're now going to see no longer represents a star, but rather the location of an individual galaxy. Each galaxy containing hundreds of billions, perhaps trillions of stars. And we live in a local galaxy group which contains about 30 galaxies large and small. Also includes the nearest large spiral to us, the Andromeda Galaxy. Only 2 million light years away, just next door, and heading right for us. We're going to get to know it pretty intimately in about 5 billion years, so mark your calendars. And as we continue zooming out, folks, you're now going to realize that galaxies are not evenly distributed out through space. Instead, the galaxies like to clump together in large groups and clusters, or they like to avoid each other where there's very few galaxies or no galaxies, voids in space. So you can kind of think of galaxies like people. They like to hang out together or they like to avoid each other. And this picture that we're looking at now, folks, represents the closest 30,000 galaxies to us in a space over 300 million light years across. We got to give thanks to an amazing astronomer by the name of Dr. Brent Tully, who worked at the University of Hawaii and compiled this amazing representation over decades of time, working aside others astronomers. So big shout out to Dr. Brent Tully. I love flying through this galactic map. But now, folks, we have automated systems that are mapping in the most distant galaxies. So now, folks, we're about to see the very large-scale structure of the universe. And remember, folks, every single point of light that you're seeing that's not a star, that's an individual galaxy. And just a heads up, the large-scale structure of the universe is not in the shape of a bow tie or a butterfly. Remember when I mentioned that we live in a big flat spiral disk of our Milky Way? Well, if you were to line up our Milky Way galaxy, it would line up just down the middle, vertically, like so. And again, we like to point our telescopes galactically north and galactically south. But astronomers still want to make sure that there was galaxies through the plane of our Milky Way, so we have this purple survey of galaxies. You'll notice that they were still able to find galaxies, just not as many and not as far. Pretty much we have to wait for our technology to improve, and once that happens, we'll be able to fill in all these areas that haven't been mapped out yet. So it's just a matter of time. And ooh, look at the time. It looks like we're running close out of time, so let's continue pressing on, folks, because now we're going to be encountering these really distant, far away objects known as the Quasars. And the Quasars are going to be represented by orange on either side of the large-scale structure of the universe. And folks, quasars are short for quasi-stellar radio sources. These blazing objects are all billions of light years away, so now we're looking so far back in the depth of time and space that the most distant quasars represent the universe at a much earlier age. We're nearing the very beginning of galaxy formation. In other words, with the quasars, we're viewing a sort of awkward, gawky teenage version of the universe, and before there was a teenager, there was a baby. So let's press back to a time before quasars, before planets, stars, and even galaxies began to form. Folks, we're about to see the very edge of the observable universe. So here we are, folks, at the very edge of the observable universe, and what we're looking at is something called the cosmic microwave background image, or the CMB image for short. And all evidence indicates that the universe that we live in is about 13.8 billion years old. This is data compiled by Planck and other radio telescopes. And this picture is a very baby version of the universe, only 380,000 years after the Big Bang occurred, where space and time began. And this isn't your typical photo either. Instead, this is a temperature density image where the light echoes of the Big Bang are color-coded, with the lighter areas corresponding to the hottest, least dense regions, and the darker areas, the coolest, densest regions. These fluctuations in temperature and density are extremely tiny. They vary no more than 1 part per 100,000. But these really tiny differences eventually gave rise to that large-scale structure of the universe that we saw moments ago, that clumping and clustering of galaxies everywhere. Figuring out just how that happened is one of the larger challenges for cosmological research today. Though our view here is of the outer edge of the known universe, folks, the earliest light visible to us, that radiation actually persists all around us. It permeates the universe, stretching and cooling as the universe expands over billions of years of time. Whew. And folks, we traveled as far back as the law of physics can physically allow us to go, so we only have one direction left to go. That's going to be back towards planet Earth, towards home. So let's find a nice entry point through all these quasars and galaxies. And this looks like a good spot. And let's make a return trip back to planet Earth, everybody. Alrighty, everybody, we're crossing an expanse of over 13 billion light years. We present you with this view of our universe and the latest in cosmological and astronomical information. We're covering eons and observing objects billions of light years apart. We live in a golden age of astronomy with new generations of telescopes and spacecrafts that are extending the reaches of our eyes, preparing for the eventual race between the advancement of technology and the accelerating expansion of the universe. And with that thought, everyone, I want to remind you all that astronomy is for everyone. You don't need to be a rocket scientist to enjoy the beauties and wonders of our universe. All you need is the night sky, and if you can, get away from the lights of our cities and look up. Even a good pair of binoculars makes for a decent first telescope, and there's astronomy clubs all around the world that invite people just like you to look through their telescopes and peer into the great beyond, allowing you to partake in the wonders that our universe has to offer. Astronomy as a hobby can offer an endless supply of satisfaction, and I do hope you'll join us, those who dream amongst the stars. But it looks like we just made our way back into our Milky Way galaxy. We're heading straight through that radiosphere, making our way to our own star system, our solar system, our small neighborhood in the vastness of space. And now, folks, we're about to pass the spacecrafts we sent out in the 1970s to explore our solar system, passing the orbit of Pluto and the Kuiper Belt region, and making our way to the third rock from the sun, our homeworld, planet Earth. All the people that we know, love, ever learned about in history all lived on this one planet. And now, folks, we're about to pass the orbit of the moon, the furthest we've ever sent humans out into outer space. And as we make our final approach back to planet Earth, folks, this is going to be the end of our tour of the universe. And I want to thank y'all for stopping by and watching it with us today. If you want to watch this exact show, we have it on the Morrison Planetarium's Facebook and YouTube page, so you can share this with your friends and family who weren't able to make it today. But hey, look at that. We made it back home safe and sound and just in time for dinner. And that's all for today, folks. Thank you, everybody, and I hope you get home safely.